So you would have done that x to that x and that x to that 5, which would have gotten you x squared minus 5x. Then you would have done that 3 to that x and put it with the other x. And then that 3 times that 5 minus 15, and then gathered it all up. Over here, in this one, you don't really have a choice. I mean, there is a little shortcut. You can memorize it, but it's much easier, I find, just to distribute 3 times. 1, 2, 3, which gets you x cubed minus 3x squared plus 7x. And then 1, 2, 3 plus 2x squared minus 6x plus 14, and then gather it up. Now, the thing that you need to see here is that it doesn't matter how big either of these two polynomials are. I could have a quintinomial out here, which is not a word we ever use, but it is a real word, and a quintinomial over here, and that would just means I would be distributing 25 times. Does everybody understand what I'm saying? You distribute everything on the left into everything on the right. It doesn't matter how long they are. The problem comes when you have to set it up to collect your like terms. And that's why I like to stack it. For every term over here, I do a line over here, and I keep the groups together. Everybody good? And then this one looks tricky, but it's not, because this, bing, this is all one thing, isn't it? Right? So it just goes to both of these. Now there's no number out in front, so that number doesn't change. 2, does the x value change? Yes, to what? X cubed, because this x has a 1. Does the y change? Not in this one. Plus, now, does the x change? Over here now, Kevin. Does the x change?
The x for 4y changes because there was no x previously.
Oh, I see, I understand. And the y becomes y to the 4th. And then this is the only kind of factoring I've taught you so far. It is Gcf factoring, and it is 3 steps. Step 1, choose the GCF. What is the greatest common factor of 16, 12, and 6? 2. So I know I'm dividing everything by 2. Is there a letter that's common to all of them? X. How many x's? 1, because this guy only has 1 x. Any y's? Only 1 again, because this guy only has 1. So everything is being divided by 2xy. So that's step 1. I decided on my GCF. Step 2, I divide everything by the GCF. Did that. Step 3, I write it out. GCF, quotient 1, plus or minus quotient 2, and so on. GCF, 2xy. First quotient, 8xy squared, plus 6y minus 3x squared. Now, if you're away on Friday, this last bit might be, that's the first time you're seeing it, unless you watched a video. But it's pretty self-explanatory, right? Choose the GCF, which we've already practiced. Divide by it, which we've already practiced from our exponents unit. The only thing that's new is writing it out like this, with the GCF first and then all your answers, and this word, factor. Remember, factors are things that multiply together. If I multiplied this and distributed this in here, I would get this back. Does everyone understand that? Which means you can always check your work in this unit. Because if I distribute this and get something other than this, I've made a mistake. Everybody understand? Okay. I left you with what work? I cannot remember. Oh, 128. We got up to 128, and then I wanted you to do this little bit of 129, which was just expansion, just extra practice there. This one we just did, x squared plus 2x minus 15. 6x squared minus 8xy. We're on page 129, everyone. X squared plus 6x plus 12 and x squared minus 6x plus 12. All right, sorry, 8. Thank you. 8. I was talking about 6 right there, thinking about multiplying. Okay, now we're going to do something a little weird here. Please turn back to page 126. And remember, we left that page blank, yes? At the bottom, we left the third one blank because I said that was a new kind of factoring, and we're ready to move on to that now. Now, before I move on to it, I need to remind you guys of something because this is one of the times that algebra tiles actually help a little bit, okay? I'm not going to make you draw it right now. I just want you to think about this, okay? Is that what I just highlighted a product or factors? It's a product, right? Which means if I was going to draw it, it would look like this, yes? And the factors would be on the sides, and the product would be in the middle, correct? Now we know when we draw this, it has to make a rectangle, right? So let's look at this, and we can see that it's got an x squared, it's got x's, and it's got 7, right? So I know I'm going to need some big boxes, some bars, and some little guys, and the bars are shaded in. Everybody understands that, right? Okay. How many big boxes do I have? 1, because there's 1x squared there, right? So if I were to draw that in there, there's my x squared. Is everybody okay with that? What does that mean the two factors are to make x squared? What do I need to draw here and here to make that? I need to draw the bar, right? Everybody's cool with that, right? X times x gets me x squared, yeah? Right? Okay. And they have to be positive to make this, right? Now, I also have negative 8 of the bars need to be in this answer, don't they? Everybody agree? So I need some negatives somewhere, right? I don't have any yet. So I'm going to need some negatives somewhere in the factors. I know my last number is going to be positive. So in the middle here, I need white boxes, don't I? But somewhere I have to make these black bars. So what does that mean has to happen out here? What has to happen to my factors to create positives in the middle and negatives in the middle. I need to have some negatives in the factors somewhere, don't I? So I will win out, right? So I know I'm going to need some negatives here and here. So now I have to make my decision. I know I need 8 of these guys. 4, 5, 6, 7, 8. And they're all negative, right? And I need 7 of these guys. 1, 2, 3, 4, 5, 6, 7. Agreed? And I know I need to make a rectangle. Right? Well, start with that. Because this is already in a rectangle, right? We can make 8 a rectangle of 8 in lots of ways. Sideways, vertical, doesn't matter. How can I make a rectangle out of 7? I really only have one option, don't I? What is it? Remember, a rectangle has a length and a width. And I need that length and width to have an area of 7. What is the only way I can do it? 1 and 7, correct? Because if I do 6 and 1, that's not a rectangle, is it? Right? If I put this one up here, I still don't have a rectangle, do I? I have this shape. Everybody with me? So to do a rectangle, like Aiden says, I got to have 1 and 7, right? And they're positive. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Did that make a rectangle? It did, right? Now, how long is this side of the rectangle? How long is that right there? One little guy, right? And how long is this side? 7 little guys, right? 1, 2, 3, 4, 5, 6, 7. Everybody cool? Now, if I finish this right now, this is a positive x times a positive 1. What kind of bar would I draw here? A positive 1. Is that what I want? So where do the negatives have to go?
You have to make both the products that are all the products that are counting as a 1 all negative.
If these are all negative, and again, you didn't have to draw this, I just really wanted you thinking about it. Now, positive x times negative 1, what do I get? Negative. And that's going to happen 7 more times, right? Everyone agree? Down here, negative 1 times a positive x. What is it? Negative. Now look. There's 1x squared. Got it. 1, 2, 3, 4, 5, 6, 7, 8 negative x's. Got it. And 1, 2, 3, 4, 5, 6, 7 ones. Positive. Got it. And you can all see that it makes a nice, tidy rectangle. Is everybody with me? Okay. Now, hopefully, you could now say, we know the 2 factors, don't we? What is this factor down here? What is that? X minus 1, right? What's this factor? X minus 7, right? Now, look closely at that. X, X, no numbers out in front. Can we do the shortcut if we were going to expand it? What is the shortcut again? X squared, what do I do with the 2 numbers? Add them. Negative 1 and negative 7 is negative 8x. And what do I do with them the second time? Multiply them to get 7. Does everybody see what I did? This was expansion. I added them together to get 8. I multiplied them together to get 7, right? But in this question, think back to the beginning. I only had this, didn't I? But my factors Got to shrink this down a little so it all fits on the screen. You will notice that, I hope you noticed, that that product gave me this. And in that original product of x squared minus 8x plus 7, I needed to find two numbers that multiplied to 7, and added to negative 8. Everybody with me? All right, now turn back to 129 so we can talk about that. So you can see this is the second type of factoring. The first type, type 1, number 1, was GCF. That's the one we did on Friday. That's the one that we are always supposed to try every chance we can, right? So let's look at, now we're going to look at the second one. Here is an example question. Is this a product or factors? It's factors, right? Because this, factor 1, is going to multiply right there by factor 2, right? And I gave you guys a new word for this, expansion, yeah? So if we expand it, we're going to get x squared, and we can do our shortcut because there's no number in front of x. So what's 4 plus 6? 10x. And what's 4 times 6? 24, right? Why did we automatically know that? Because we did 4 plus 6. Why did we automatically know that? Because we did 4 times 6, right? Which means if that worked with expansion going that way, then it must work with factoring going the other way. So when I go the other way, back this way, and I factor, I must need numbers that add to 10 and multiply to 24. Why do we call it factoring? Because we need factors of 24. Now, sometimes you see it immediately, and sometimes you have to work it out. So I always go, okay, well, 1 and 24, they will not go together in any way to make 10, will they? 2 and 12, they could go together to make 10. How? 12 minus 2. But since everything's positive, I obviously can't have a negative in my factors, can I? So 12 and 2 won't work. 3 and 8, that doesn't make 10. 4 and 6, that makes 10. And since everything's positive, I use 4 and 6. Is everybody with me? It's exactly the same thing as this, but we're working backwards. So let's look at this one. Since it's a trinomial, and since it starts with an x squared, if we can factor it, it's going to eventually look like this. X plus or minus some number, right? And then x plus or minus some number, correct? And we know those numbers have to add to what? 7 and multiply to what? Look closer. Negative 18. So now I need numbers that will multiply to 18 and add to 7. And since I have a negative, I know I'm going to need a negative somewhere, aren't I? Will 1 and 18 make 7 in any way? No. Will 2 and 9 make 7 in any way? How? 9 minus 2, right? So I need a positive 9 and a negative 2. So I come back to my list here and I say, okay, I need a positive 9, and I need a negative 2. And then I check. Is x times x x squared? So I'm right. Is negative 2x plus 9x 7x? Negative 2 plus 9, 7. Yup. And then I check. Is negative 9, or positive 9 times negative 2, negative 18? Yup. And I'm done. Does everyone see how easy it is? We're only dividing one number. Right? So let's look at the second one here. What do I need numbers that will multiply to? Which is the multiply one, the negative 2 or the negative 8? Negative 8. So I need to multiply to negative 8 and add to what? Negative 2. And then I just think of the numbers, the factors of 8. First factors of 8, 1 and 8. Will that get me to 2? 1 and 8 will get me to 2, Ayaka? No. 2 and 4? How? 4 minus 2? 4 take away 2. What's that? That's positive 2. Do I want positive 2? What do I want? Negative 2. So I must be doing 2 and negative 4. Does everyone understand? So I have x plus 2 and x minus 4. And then I check. Is 2 minus 4 negative 2? Yeah. Is 2 times 4 negative 8? So did I factor it correctly? Yes. Now let me ask you this. Would I be allowed to write it this way? Is that okay? Yes. Why? It's the same thing. Is 5 times 2 the same as 2 times 5? Yes. Would I be allowed to write it this way? Oops. Is that okay? No. Because even though 4 times negative 2 is negative 8, 4 minus 2 is not negative 2. Does everybody understand? All right. You try C. Remember, you need to add to something and multiply to something. Foot's already asleep. Especially when I've been doing it for 20 years and don't remember and still insist on doing it. What do I need to add to? Who's going to take the lead here?
Negative 12.
And what do I need to multiply to?
35.
Is it 35 and 1?
No. Oh, yeah. What?
No.
Is it 35 and 1? No. Is it 5 and 7?
Yes.
Yes. What kind of 5 and 7? They both have to be negative. X minus 5, x minus 7. Now, hopefully you're noticing something. If the last one's negative, then I needed a positive and a negative, didn't I? The last one was negative. I needed a positive and a negative. The last one here is positive. So I can't have two different signs, can I? But since this one's negative, I need two negatives. Is everybody good with this? All right. Now, what's different in D from a math standpoint? I know it's first thing Monday morning, but all of you can see that something is different in D. I added the rule, it has to be from a mathematical standpoint. I'll make it slightly easier. What's different, Evan? The variable is an A. Does that change the math? No, of course it doesn't. So, I look at this and I say to myself, self, I need two numbers that will multiply to what? Negative 20. And add to what? Positive 12. And since that's negative, I know I need A plus and A minus, don't I? Is it 1 and 20? No. Is it 2 and 10? 2 and 10. Okay. Which one of those would be the positive one? You're hesitant to say 10 because you see that it's not going to work, don't you?
Yes.
If I make that 10 and I make that 2, what's 10 minus 2? 8. I need 12. Okay, Myers, don't you mess with me. You're not fooling anybody. It's plus 2 minus 10. Isn't it? Except, is it? What is 2 minus 10? Minus 8. What do I need? 12. So it can't be 2 and 10, can it? Is it 4 and 5? Well, 4 and 5 will multiply to 20, but will they give me 12 in any way? So if 1 and 20 doesn't work, 2 and 10 doesn't work, 5 and 4 doesn't work, 6 and 6 doesn't work because 6 times 6 isn't 20, the question becomes, can we do this? No. And that is a big problem for my math students. Sometimes you people forget that there's times you just can't do it. There are no factors here. But you will sit for 20 minutes trying to make it work, even though it can't. Do you understand what I am saying? It is just as important to know when you're done as it is to know how to get to being done. Does everybody understand that? So what we write here, instead of, we can try the work, but at the end of it all, we have to say that that doesn't factor. Now there's a double-edged sword to this as well. Once I have given you this option, that it's possible to have a polynomial that you can't factor, a ton of you on your tests and quizzes are going to say, oh, that one doesn't factor, Mr. Myers, because you don't see it right away. Do you understand the problem with that? That is why you always check at the end. Because everyone who was paying attention nodded and said, oh, it's 10 and 2. And then when we wrote it out, as soon as you checked it, no. Everybody understand? All right, we're going to practice this a ton. You guys do E, because E works. Try it. Remember, if you don't actually know what you're doing, at the very least, follow the steps. I need numbers that multiply to what? Which of these is the multiply one? The negative 14. And I need to add to what? Negative 5. If you see it in your head, you see it in your head. But some kids don't. So I say, write out the factors. Is it 1 and 14?
No.
Can't be. Is it 2 and 7?
Yes.
Yes. 2 and 7 will make 5. How does 2 and 7 make negative 5, though? 2 minus 7. So then I just write it out. Y plus 2, there's my plus 2. Y minus 7. And then do I check? What is 2 minus 7? Negative 5. What is 2 times negative 7? Negative 14. Am I right? Yes. Everybody good? All right. Stop for a moment. Take a nice deep breath. Because now it's going to change. All right. Look at F and tell me what you don't like about it. That the coefficient 4 is new, isn't it? Right? We don't like that. Because, Mr. Myers, you've only taught us what to do when there's nothing out in front. Correct? So right now there's a 4 there. We don't like that 4 there. What math is happening with that 4? It's multiplying. What would get rid of multiplying? Division. Oh, okay. But if I divide this by something, doesn't that change the whole expression? Unless you divide everything. So if I need to get rid of that 4, hey, wait a minute. Isn't that GCF factoring that we were just taught? So that's your first warning. Remember, I told you, GCF first. The best hint to GCF is if there's a coefficient in front of the x. You want to try to GCF. Now, if you weren't here Friday, you're a step behind, but that's okay because I just showed you. Did I choose a GCF? It's 4. So now I rewrite this, right? How do I rewrite it? What goes first? The GCF and then the answers, right? So 4 divided by 4 is x squared, correct? What's 20 divided by 4? 5. Negative 5x. And 56 divided by 4 is what? Negative 14. Now, look closely. Aren't those the exact same polynomials? That's the next thing I have to warn you about. Remember I said in GCF, sometimes you have to factor again. So we factored once, we took out a GCF, and then we already know what this is, right? So remember, sometimes you factor more than once. So we know this. So can we forget about this 4? No. But we know this is x plus 2 and x minus 7. Is everybody cool with F? It's just putting together the stuff we did on Friday and the stuff we just learned. Everybody good? All right. Look at G. Tell me what you don't like. I don't like the 10. So I got to get rid of it. What gets rid of times 10? Divide by 10. Where does the 10 go? To the front. And what goes in the brackets now? I know, it's tough. What goes in the brackets now? All these answers. X squared plus 8x plus 12. Now, I need numbers that do what to 12? Multiply to 12 and add to... What do they have to add to? He waited patiently. 8. Is it 1 and 12? Is it 2 and 6? Yep. 2 and 6. 2 plus 6 makes positive 8, so that's my pair, right? So it's 10, x plus 2, x plus 6. Everybody good? All right. Look at h. Tell me what you don't like. There's now 2 things you shouldn't like in h. It's a negative 4, isn't it? I still want to get rid of the 4, but I also want to get rid of the negative, don't I? So what do I divide by instead? I'm not going to just divide by 4. What am I going to divide by? Negative 4. And then I'm going to rewrite it. Negative 4 t squared. What happens here? Positive 4t minus, I'll help you out because I don't want you to have to get out your calculator, 32. Right? Am I done? I have to check. I might find a pair of numbers that do what and what. What would they multiply to? Negative 32. And what would they add to? Positive 4. Is it 1 and 32? 2 and 16? 4 and 8? 4 and 8. 4 and 8. One of them needs to be negative. Which one? How will I get positive 4? Is it 8 minus 4 or 4 minus 8? 8 minus 4. So I write it out. Negative 4 t minus 4 t plus 8. Is everybody good? Okay. Now tell me what you don't like about I. It's backwards. Can we change the order? Sure we can. So let's write it the way we want to write it. Negative d squared minus 5d minus 24. Are we happy with that? What don't we like there, Zara? I don't like that negative. What is that negative really? Negative what? Negative 1. So if I divide everything by negative 1, I'm going to bring a negative 1 out front. And what do I get in the middle? D squared plus 5d plus 24, correct? And then I would need numbers that multiply to 24 and add to 5. Is it 1 and 24? Nope. 2 and 12? Nope. 3 and 8?
Yes.
Maybe. Let's check. 3 and 8. I need this to be positive, so these would have to both be the same sign, correct? So negative 3 minus 8. What's that? Negative 3 minus 8 is negative 11. What did I need? 5. So it can't be 3 and 8. Can it be 4 and 6? No, it can't. So are we done? It did factor once. We were able to take out the negative. But we're done here. Does everybody understand? Okay. Tell me what you don't like about J. There's two variables, right? Everyone agrees, yeah? If that and that wasn't there, could you do it? What would you do if that was the question? What would you be looking for? Numbers that multiply to what? What kind of 20? Negative 20, and add to what? Positive 19. Is it 1 and 20? Yeah, right? So we know it's going to be 1 and 20. How can I put 1 and 20 together to get 19?
20 minus 1.
Everybody cool that it's 20 minus 1? So 20 minus 1. And then I write it out. V plus 20 and V minus 1, correct? Okay. V times V gets me V squared, right? What would I need to get a B squared?
2b.
I need two B's. Where would they go? 20B and negative 1B. Would I write negative 1B? What would I write? Negative B. Does everybody understand? Did anything change? Nope. Can I still check it the same way? Is 20 minus 1 19? Is 20 times negative 1 negative 20? Is B times B B squared? So did we do it? Great. You guys try K. Because K is exactly the same as J. If you're still a little nervous, you're still a little uncomfortable, just try to do a step or two. And you don't have to broadcast this, but is everybody in the room okay with this part? Do you all understand you got to multiply to the last guy and add to the middle guy? Is everyone okay there? Okay. So then all we got to do is work with 28. You should have been listening to me. What do I always start with? 1 and 28, right? Okay. Now, 28's even. So does 2 work? 2 and 14. So we know it's not 1 and 28. Will 2 and 14 make 12 in any way? How? 14 minus 2. Everyone agree? Now I have a positive and a negative. Will that multiply to get me a negative number? So am I okay? All right. So I know it's x. I know it's negative 2, right? I know it's x. I know it's negative 2. I know it's x, and I know it's positive 14. What's the only thing I'm missing? I need that y squared. So what do I have to put here and here? Y and y. And then y times y gets me y squared. Everybody good? What's weird about L? Notice what I've been doing with all of these when I make it slightly more difficult, right? I've asked you guys what's wrong, because you know how to do now 2 different versions of this. Here's a third version. What's wrong in L that you have not seen before? Evan? There's a cube. Haven't seen that, right? What did you see, Aiden? There's a B in everything, which means I got to get rid of that B, don't I? Because I don't like that B out front. If I want to get rid of a squared times b, what would I do? What do I do to get rid of times something? I'm going to divide by b. Oh, there's a b there. Oh, there's a b there. Now, Evan, what's going to happen when I do b cubed divided by b? I think you know. What is the it's going to be what? B squared. And we know what to do when it's a squared, don't we? So by getting rid of that b, which is exactly what we did up here to get rid of that 4, we took care of the thing you noticed, which was the cube, right? So what goes out front? B b, same way as up here, we put the 4 out front. And what's in the middle? A squared minus ab minus 20b squared. What number should be there that isn't? Where the red dot is. What number should be there that we didn't write? 1. So I know I need to multiply to what? Minus 20, and add to what? Minus 1. Is it 1 and 20?
No.
Nope. 2 and 10? Will 2 and 10 get me to 1? No. 5 and 4? Yup. How does 5 and 4 get me to negative 1? 4 minus 5, right? So I just write it out. A plus 4, which I got from right there. I needed a b, so I got to remember that b. And a minus 5b. Everybody good? Everyone is good? Okay. What's different in m? What's different? There's 4, isn't there? Oh, I know what to do with this. I just got to divide by x, don't I? That changes it. Why can't I do that? There's no x here. Right? So now I got to think, all right, well, that's not going to work. Look back at what you know. When it was x squared, it was x and x, correct? A squared, a and a. Well, now it's x to the 4th. X squared and x squared. Is x squared times x squared x to the 4th? So I've taken care of the thing that bugged me now, yeah? And now we can go back to what we were doing. Multiply to what? 50. And add to what?
15.
Negative 15. Is it 1 and 50? 2 and 25? 5 and 10? It's 5 and 10. Now, how do I get 10 and 5 to get me negative 15? I got to have negative 10 and negative 5, don't I? So, x squared minus 10, x squared minus 5, and I'm done. Does everybody see how it all comes back to the very, very first thing we learned? This trick. It all comes back to distributing, right? What's weird about n? Oh, sorry, Evan, what?
Where's the big X? Where's x squared?
X. Oh, that's just a bracket. Yeah, it's just crappy writing. That's the 2 brackets bumped together. It's this. X squared minus 10, bracket, x squared minus 5. I know some teachers make their x's that way, and it's always bothered me because of exactly what you just said. It looks like an x, but it also looks like brackets. That's why I always try to make my x's like that. All right. What's different in n? There's a 0 in the middle. But other than that, it looks the same, doesn't it? So I would need numbers that multiply to what? No. Multiply to negative 9 and add to what? 0. Is it 1 and 9? Is it 3 and 3? How? How will 3 and 3 get 0? Minus 3. So it must be x plus 3, x minus 3, correct? Right? Oh. Look at this closely. What do you notice about that number, and that number? Do we know something to do with 3 and 9? It's a perfect square, isn't it? What do you notice about x squared? What's it? A perfect square, isn't it? x plus 3, x minus 3, x and negative 9, x plus 3, x minus 3. What do I have in O? I have x squared and 625. Is that a perfect square? Is it? Is it on your list of perfect squares? It's not on your list, but it is a perfect square, isn't it? So, it's x plus what? We use 3 and 3 because that's the square root of 9. So what do I do here? Square root of 625, which is 25. What was the hint in N and O that you needed the square roots? That's 0, correct? Now, as a math teacher, I put 0 there on purpose. Why? To show you that hint. As a mathematician, would I ever write that 0? What would I really write here instead? X squared, 1? It's 0x. Would I ever write it? It would be x squared minus 9, wouldn't it? Wouldn't it? And what would this one really be?
X squared minus 625.
Please notice the little pattern. It's going to come back in a minute. Squared, 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 squared. Square root, square root. It's going to come back to you not in a minute. It's going to come back tomorrow or the next day. Everybody with me? You guys do the last one on your own. It's tricky. A little. There's a proper way to write the answer. That's where it's going to get tricky. What do I need to multiply to? 16. What do I need to add to? 8. Is it 1 and 16? 2 and 6? Or 2 and 8? 4 and 4? X plus 4. X plus 4. Would we write it that way?
No, squared.
What would we write?
X plus 4.
Is everybody cool? Okay, now it's story time. This factoring used to be in grade 9 years and years ago. And I was teaching a kid in grade 9. And he was a great kid. I love this kid. He was a super kid. He was really, really nice kid. Played rugby, good kid, great kid. Loved him to death. Couldn't do math. And when I say couldn't do math, I know some of you feel you can't do math. But if I asked you to put your hand up if you feel math is one of your weak subjects, a bunch of you would put your hand up, right? And I would say something like this. Kevin, what's 11 plus 6? And you'd say 17 and you'd be right. This kid couldn't do that. Okay, that's how bad his math was. You with me? Everybody with me? We started doing this, and I was like, oh man, this is going to be so hard for kid. This is going to make me so sad, because I really liked this kid. I really wanted him to do really well. But he was having so much trouble. So I started doing it just like I did this. Okay, it's got to add to what, multiply to what. And for some reason, this kid saw the pairs immediately. He never had to write it down. He never had to go, is it 1 and 20, 4 and 5? As soon as he looked at this, he would say, 10 and negative 10, negative 5. And that's the only thing all year that he could ever do. Just this. And I still, to this day, do not understand it. I asked the kid, I said, kid, everybody thinks factoring is the hardest thing. And he's like, it's so much easier than everything else. And I would give him tricky ones. I'd try to fool him. And he'd be like, that one doesn't work. One's like the 10 and 2 with the 12 there. He'd look at it right away. Can't do it. Write down the right answer. I don't know. But he would know that it could or couldn't work, and he would know the pair. But then he wouldn't write it out properly. It's -2 and 14, Mr. Myers. Okay, write it down. No. It was the weirdest thing. Okay. I believe your next page is page 131. And I believe it is entitled Factoring with, that is called Casino Queen. Because if you look closely, you can see there are card suits in the letters. Yeah? I call it an assignment, but it's not because it's your first attempt at some of this factoring. All right? 131 is your homework tonight. Quiz tomorrow. Quiz on expansion and on Gcf Factoring, which is pages 127 and 128. Okay? Where did it go? I was just writing it. Where did it go? Where did it? Oh, there it is. Pages 127 to 128. Okay? Now, rugby guys, are you okay with the division one, dividing? This one, where if I said 6x squared plus 5x, not 5, plus 12x y minus 18, and you would take out a 6, because that goes into all of them. So it would be 6 x squared plus 2xy minus 3. You're cool with that? And then if there was a letter here, say there was a y or an x there, x squared there, we take out an x, and this would become x and 3x. You good? Okay. Yep. Yep. Yeah, out of 6 times.